My name is Saranaja, and you're watching Growing Security. We're on day 11 of the advent of cyber, and today's topic is XSS Mary Xmas. This room didn't load for me. Don't know why there must be some error. Let us start with the room. So the story goes like after last year's automation and tech modernization, Santa's workshop got a new makeover. McSkidy has a secure message portal where you can contact her directly with any questions and concerns. However, lately the log has been lighting up with unusual activity, ranging from odd messages to suspicious search terms. Even Santa's letters appear to be scripts or random code. Your mission, should you choose to accept it, dig through the logs, uncover the mischief, and figure out who's trying to mess with McSkidy. Learning objectives, understand how XSS works, and learn how to prevent XSS attacks. What is XSS? It stands for cross-site scripting. Type of security vulnerability typically found in web applications where you have input forms, like when you have a input field that expects the users to enter any form of text, or it also allows attackers to run malicious code through that text form. Now if you enter a script tag from HTML, now whatever website you build, at the end it is just HTML, CSS, and JavaScript, right? No matter which frameworks you use, basically for MERN and mean stacks. We have a tag box today, and we will start everything. Leave the cookies, take the payload. Equipment check. For today's room, we will be using the web app found under this machine IP. If you use the browser of your tag box, you use you can use the browser of your attack box to navigate to it. You will see the page as shown below. Yes, you can see this input box. We are going to mess around with this input box and see what happens. Let's review key material regarding potential attacks on website like this portal, specifically cross-site scripting. Web application vulnerability: let attackers inject malicious code, usually JavaScript, into input fields that reflect content viewed by other user, where an application doesn't properly validate or escape user input. Now, what that simply means, when you design web applications, you need to ensure that whatever inputs you take from the user, you have to sanitize that input, meaning you cannot allow any users to just come and write whatever they want to, because of this XSS vulnerability. You have to sanitize input, means you have to ensure that only the right type of input is received from the front end. Result: a malicious code that can steal credentials, deface pages, or impersonate users. Depending on the result, there are various types of cross-site scripting. In today's task, we focus on reflected and stored. For reflected, for example, you take a toy search function in an online store. This is the store, and search with this query term is equals to gift. In a URL, whatever is present after the question mark, it is a parameter that is used for searching or listing or taking your input. But imagine you send this to your friend who is looking for a gift for their nephew. Please don't do this. TryHackMe gives search term. Now you entered a script tag A to B, and this is something. If your friend clicks on the link, it will execute the code instead. That is reflected CSS. What is reflected XSS? Whenever you, it is a type of XSS when whatever malicious code or whatever you did come back to you. For example, you put an alert in this code, and that will be prompted to you or any person that refers to that client side. It is not permanently stored at a server or a database. It only stays at the client side, and whenever that particular URL is visited again, this script is ran, or whatever code you have written over here. You could act, view information, or modify information that your friend or any user could do, view, or access. It's usually exploited using phishing to trick users into clicking a link with malicious code injected. Now, if your friend who is from non-technical background, he wouldn't understand if you send this to them, right? You should not. You can just say hi in that way, but nothing malicious. Then we have stored XSS. Stored XSS occurs when malicious script is saved on server and then loaded for every user who views the affected page. That means you stored it at the server itself. Now, whoever fetches that particular resource from the server will face this. Whatever script you have written, it will run it. Becomes a set and forget attack. Anyone who loads the page runs the attacker's script. Normal comment submission. Let us first visit this page. We have previous message, send message, and system logs. We did a search. Send your Christmas wishes and questions to Santa's chief security elf. Normal comment submission. Post is an HTTP method. Post tgm review your gif dot thm. Post ID is 3. Name is whatever. Email and comment this gift set my carpet on fire, but my kid loved it. The server stores this information and displays it whenever someone visits that blog post. I think, is it over here? Malicious comment submission, stored XSS example. If the application does not sanitize or filter input, an attacker can submit JavaScript instead of the comment. Here, because the comment is saved in a database, every user opens will automatically trigger the script. This lets the attacker run codes as if they were the victim in order to perform malicious actions such as steal session cookies, trigger fake login pop-ups, and deface the page. Protecting against XSS, disable dangerous rendering paths. Instead of using inner HTML property, in JavaScript we use this inner HTML property to write the contents in a HTML tag using JavaScript, which lets you inject any content directly into HTML. Use text content property instead. It treats input as text and parses it for HTML. In inner HTML, you can input any form of content dynamically using JavaScript, but in text content, you can only input text. Make cookies accessible to JavaScript. Set session cookies with HTTP only, secure, and same site attributes to reduce the impact of XSS attack. Sanitize input, output, and encode. In some situations, application may need to accept limited HTML input, for example, to allow users to include safe links or basic formatting. However, it's critical to sanitize and encode all user supplied data to prevent security vulnerabilities. Sanitizing and encoding removes or escapes any elements that could interpret as executable, such as scripts, event handlers, and JavaScript URLs for parsing while preserving safe formatting. To exploit XSS vulnerabilities, we need some type of input field to inject code. If they don't ask for input, there is no XSS. But dynamic web applications do need input fields. You just have to sanitize it. That is the solution. There is search section. Let's start here. Exploiting reflected CSS. Let us try to run this over here. Pasting this search messages. And we found reflected meow meow, meaning our XSS attack was successful. The search input is reflected directly in the results without encoding. The browser interprets your HTML, JavaScript as executable code. An alert box appeared demonstrating successful execution. You can track the behavior and how system interprets your actions by checking the system logs. Ooh, we found a flag. Evil bunny. XSS detected in search. User agent is our Mozilla Firefox Ubuntu Linux. Now to check for stored XSS, we are going to go to the message section and type in this code. Send message. Stored meow meow. You will get another flag. It is said in green. Message posted script. The message is also posted, the script is also saved. Which type of XSS attack requires payload to be persistent in the backend? Stored. We are done with the room, and that final page came now. That is it for today. See you in the next challenge.